أعوذ بالله من الشيطان الرجيم رب اشرح لي صدري ويسر لي أمري واحلل عقدة من لساني يفقهوا قولي سبحان الله والحمد لله ولا إله إلا الله والله أكبر ولا حول ولا قوة إلا بالله العلي العظيم اللهم صل على محمد وعلى آل محمد كما صليت على إبراهيم وعلى آل إبراهيم إنك حميد مجيد. My today's video is pretty simple. In this video, we will calculate the time it takes for a block to slide from point A to origin on a hyperbola. So the curve this time, as compared to my previous videos, video 23 in which I took straight line, and in my video 25 I took a parabola. So, but in this video I will use the hyperbola. Okay, so this curve is the hyperbola. This curve is the hyperbola y plus 1 whole square minus 6x square over pi square is equal to 1. Hyperbola, the required one. And one branch of the hyperbola, the top branch of the hyperbola is given by this. The second branch, the one with the negative sign here, is downward, and we are not concerned about it. So we are not going to consider that. So we are going to take this branch of the hyperbola, which is this. When we solve this with the plus sign, we get minus 1 plus blah blah blah. Okay, so its derivative is dy by dx here, which is equal to tan beta. Beta is Tahirian angle, the angle that the tangent makes with the positive x-axis. Tan beta at A, the condition of sliding, when we leave the block at point A, then tan of beta A, the tan of the tangent at that point, should be equal to dy by dx at A, and it should be greater than mu, the coefficient of friction, 0.5, which is the condition of sliding. It should be because we leave it at rest and then we let it go down. If this is not greater than this, then it won't slide, it stay there forever. Okay, so g is equal to 9.81 meter per second is the acceleration due to gravity approximate near the surface of the earth. Okay, so the time taken from point A to, for the block to slide down from point A to origin, the parabola passes through the origin, is given by minus the integral of 2 pi, which is approximately 6.28. So 2 pi 0 to 1 plus blah 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 blah. This is given in my video 25. This expression has been derived in my video 25. So if you want to learn about how it was derived, about the derivation, you can watch my video 25. And you can also watch my video 23 because it's before that and it's related to it. This video will explain this and this video will explain this. Okay, so we calculate here, we put the value of dy by dx here, tan inverse dy by dx, tan inverse dy by dx, 1 plus dy by dx whole square, dy by dx whole square, minus 2g times g is equal to 9.81 meter per second square, y minus mu x, arbitrary point, y here, y minus 0.5 mu times x, arbitrary point, or the variable of integration, plus 2 times g 9.81 times ya minus mu xa. Mu xa is mu times 2 pi, which is pi, and ya is 4. So as you know in my previous video, because eventually I'm going to compare the times of all these with the time of the cycloid, and we can easily fix a cusp of the cycloid with this ratio 2 pi 4 0 0. We can easily fix a cusp of the cycloid perfectly. So eventually when I find the time for the cycloid in my incoming videos, I will compare all this with the time of the a block takes to slide down on a cycloid and the time it takes to slide down on these curves. Okay, so you can simplify it further the way you like, and then you can integrate by using trapezoidal rule. Trapezoidal rule, if you take infinite terms, I mean if you divide the area under the curve in infinite subdivisions, then trapezoidal rule will give you the value correct to infinite decimal places. So it's the exact trapezoidal rule gives the exact answer. So you can use as many subdivisions as you like, or you can use an online calculator and put this value or any other simplified form of this integral 6.28, then you will get this value 3.453 seconds. So in my video 23, 25 and 26, you can see that the time it takes to slide down on a straight line is greater than the time it takes to slide down on a hyperbola, and the time it takes for a block to slide down on a hyperbola between the same points. These curves are compared with the same point 2 pi 4 and 0, 2 pi meter and 4 meter and 0 0. It's a little bit more between 7 and 8 or something, 8 meters. Okay, so this one for the straight line is greater than the hyperbola, and the time it takes to travel on the hyperbola is greater than the time it takes to travel on the parabola. So far the race, the winner is the parabola. Okay, so in the next video we will try, I think I will do the cycloid, and we'll see the cycloid, what time the cycloid gives when the same block is a cycloid, cusp of the cycloid is fixed here, and we will see how long does the block take to slide down from one cusp of the cycloid, from 2 pi meter 4 meter to 0 0. Then we will compare the time of the cycloid with this. Subhanallah walhamdulillah wa la ilaha illallah wallahu akbar wa la hawla wa la quwwata illa billahil aliyyil azim. So basically the prerequisite video is video 23. So you can watch video 23, you can watch video 24, 25, and okay, and any other video you like. Okay. Allahumma salli ala Muhammadin wa ala ali Muhammad kama sallaita ala Ibrahim wa ala ali Ibrahim innaka Hamidum Majid. Thanks for watching.